Hi, I'm Philip, and in this video I will show you how I created the two lens protectors for the Sermoon P1 scanner. I created the lens protectors because without them you have like the bare plastic and glass housing of the lenses, and I quite like laying down the scanner on its front side for like doing the post-processing or simply when transporting it in my backpack, so outside of the regular casing. And I simply don't want to scratch these rims. So I created the protectors as some kind of, I would say, bump bump protectors. They are 3D printed from TPU, like all my casings or all my protectors. So I did something quite similar for the Sermoon S1 and for other scanners. So to start with, I simply 3D scanned the Sermoon P1. And the first thing I was doing in Quicksurface is the alignment. So this I will give you more like an overview of how I approach this task in Quicksurface. I didn't capture like the whole design process. It took roughly, I would say, half an hour with and revision I wanted to add. So I started with the alignment of the scan. So normally when the scan comes out of the scanner, it isn't aligned to the coordinate system. But as you can see here, it is perfectly aligned. For this, I used first created 3 planes in the prepare scan menu. First is a symmetry plane. For this, the software guides you while creating it. Then I needed 2 additional planes for constraining it, and then you can align the scan to the coordinate system. Next thing is I saw that the 2 lenses were roughly symmetrical in the like on the scanner. So it is enough if I create the protector for 1 lens. For this, I first extract the surface of the lens and then create a sketch on this surface, or better said, it's an offset sketch from the surface. As you can see here, it's offset maybe 1 to 2 millimeters. So I'm inside this draft extrusion. For extracting the contour, I simply use the automatic fitment of a slot. So this worked quite well. When then extruding the sketch, I've seen that theoretically it isn't a perfect draft. So as you can see here, the sides fit quite well, but here and here, it's like an irregular draft with multiple draft angles, or like constructed from multiple planes. I initially thought about also using this, so more like creating this and this side as separate planes, and then the sides as additional planes, so I can cut and then draft them. But since this is only roughly 0.4 millimeters of overshoot, so it's important this would be like an additional gap between the printed part and the lenses, so it doesn't obstruct me from mounting them. I just didn't care and was happy with the result. So this is often one of the points you have to think about when doing reverse engineering or design based on 3D scans. Is like what is a good middle point between work and results. So I could have done it in a more fancier way or a more technical way, but it worked like this and it saved me a lot of time. So this is the first one. Now we construct the cutting plane. So the first cutting plane to limit the bottom side of the part is this one. And then we have a sketch on the top side. So here on the top, based on the original plane, I place on the top. And this will be like the rim around the lenses. I simply did an intersection with the plane, with the extrusion, and offset it by 2.5 millimeters to the middle, so I don't obstruct the LEDs and the camera sensors. And then I offset it a bit further to the outside because there it will be trimmed anyway. So now I can directly extrude this part by 2.5 millimeters. So for my cases, I generally like 2.5 millimeters. And the next thing is creating an additional cutting plane. So here for the center, because you can see it's like, it's angled in 2 ways. So you have this plane and this plane we will leave for cutting. And then we can first offset this surface a bit, so the extruded surface, this offset is there because it gets mounted, so the protection later is getting mounted with some double-sided adhesive tape that's normally used for smartphone repair. I quite like it. It's thin, it's reversible, and it adheres quite well to TPU parts. I simply did a surface offset of 0.05 millimeters to create a bit of a gap, but not too much because the tape is quite thin. And now I can thicken the offset surface by 2 millimeters. I initially thought about using 2.5 millimeters or even more, but as you can see, I wanted to create quite a flush fit to the side parts, to the original casing of the scanner, and with more than 2 millimeters, it wouldn't have looked so nice. And the main part I'm interested is this edge, and there will be like additional protection. Then I can start with the trimming process to like extract my shape I want. For trimming, it's important. I could theoretically directly trim all parts like this. In Quicksurface, this will only make your life harder, I would say, because then it calculates all the intersections between all parts, and this adds like quite a lot of additional cuts and additional parts I have to delete in trimming tool. But if I now make the trimming step by step, so first these two parts, then these parts and these parts, it's just way quicker, and it's also less error prone because you won't forget like very small floating bits. Initially, roughly a year down the line, I tried cutting, I think it was like 20 or 30 planes at once, and it created hundreds of intersection bodies. And I had to like delete every single one of them piece by piece. So this is just faster. Then the next steps are just regular filleting and chamfering. So they're like the new filleting tools in the 26 version of Quicksurface are really helpful. This is just my, I would say, regular filleting approach with like 1 millimeter here on the outside and 0.5 millimeter on the inside, and for the very small fillets 0.25 millimeters, just so I'm not having too sharp edges. If you're 3D printing the parts anyways, maybe you have to keep in mind a bit about the nozzle size. So with 0.2 millimeter nozzles, you will notice the difference between the different fillets, but with a 0.4 millimeter nozzle, basically 0.25 and 0.5 millimeters may look quite similar. So the next step I now want to take is creating a bit of a pedestal, so that the scanner is laying entirely flat on the table. So at this point, I printed the first version of the lens protectors. But what I noticed, that if I now create an additional plane here, like this, there is a small gap. So I just extracted a plane on the handle parts, and then there is, I would say, 0.5 to 1 millimeter gap between the table the scanner lies on and the lens protectors, and this causes a bit of wobble when tipping on a touchscreen. And I wanted to get rid of this wobble by just creating a bit of a pedestal, like you can see here in the final part. And for this, I just created this plane, and I created a sketch on this plane. This sketch is basically just that I projected the outline of the part and offset it a bit. So I have this like nice arcing part. I limited it to the sides, so it's roughly 20 millimeters tall. And this can directly be extruded. And for the extrusion, I just, the top plane is on the top distance is 0 millimeters from the plane. The bottom plane is just pulled down, so it intersects all the way with the protector. So in the next step, I can create nice fillets. I quite prefer creating the fillets before combining these parts, so I have a bit of more reliable filleting, or it's just easier. And then I can trim them together. So if I now hide the meshes, you can see the trimming task just deletes all the internal parts. And with the 26 version of Quicksurface, the trimming got quite more reliable and faster. And the last step is basically mirroring it. Is a short fillet here around the part at 0.5 millimeters, and then mirroring it. And if you're now looking at the analysis between the difference between the parts, you can see that here we have this gap where it is like no even draft, but that's fine because it's like additional space between the print and the original lens. On the other side, we can see there is a bit of asymmetry, I would say. So on this one side we have a gap, on the other side we have a negative gap. This is mainly to the fact that it isn't like perfectly symmetrical, but I printed them and both fit both sides. So I would say one of the lenses is just a bit offset by maybe 0.5 millimeter. So if you measure it, it should be, I would say, even less than 0.5 millimeter. This could even be while creating symmetry plane, or it's just a bit offset. Because as you can see, the cameras itself aren't symmetrical. So you have the high resolution cameras to one side and the ultra wide or wide angle cameras to the other side. So yeah, this is my I would say construction process for the lens protectors. I hope it helped you a bit in understanding how to approach such tasks in Quicksurface.
So the prints are finished for the lens protectors, and this is the design I've shown you in the final part. So with the slide stepping on the side, and this is the intermediate part, or the version 1, I would say, without the stepping. When revising and looking at the prints, you can actually see that I quite prefer the original parts because they have this flat surface, so I can lay them on there on the print bed like this, and the overhang here in the middle where the lens is inserted is like printed quite sharply. On the new design, I have to print them with the overhang on the bottom side, so the top surface quality isn't the best because it's like a TPU print, and also the overhang is quite rough. So I may even resort to using the original design, placing them on the scanner. You can see they fit quite nicely. Of course, now they aren't glued in place with the double-sided tape, but I would say the look is quite nice. And even with the original design, the scanner doesn't wobble. So if I'm putting them away, you can see it is prone to like falling a bit down to the front, and then it resides. But with the protectors, it's simply a bit more of a secure fit. But I guess I will upload both designs so you can decide what to print.